This video is going to show you how to connect the RL circuit using MultiSim software. This is our experiment number 3. So the circuit is having R and L and our voltage source. We need a switch. So let us get into MultiSim 13 and place all those components. Under basic, we can find our resistor, place it, then an inductor, place the inductor, close this, go to sources, power source, select a DC power source and place that also here. Then we need a ground, take the ground, it's done. Now we need a switch. The switch is available in basics. Go there, here select your switch, then go to the second column, this SPDT switch, you can see the symbol here. So the switch is also placed. Now we need to connect our circuit. Before connecting, the switch has to be flipped. So flip horizontally so that two terminals will be onto your left hand side and a single one will be on the right. Now connect it. The source, rotate your inductor, it's done. Then your ground. Now we need to give the values. Resistor is 1 kilo and the inductor is 10k and source is 5 volt. So double click on the source, change the value to be 5 volt, then double click on your inductor, it is 10 Henry, just 10 Henry, say OK. We did it. Now we need a CRO to see the output. The CRO will be in the rightmost column. Go and select your CRO, place it here, connect across your inductor. So one thing we have to note down here is we have to set our CRO time base equal to your time constant. So when you calculate the time constant, here tau is equal to L by R. So 10 divided by 1 kilo will give you 10 milliseconds. So in your time base you have to keep 10 milliseconds. Now start your simulation by clicking the run button, and we have to operate the switch using your spacebar. So it's very fast. So what you do, go and just increase your time little bit. I kept at 20 milli. Again, able to see how it is plotting? Yes. Now when you get in a stop your simulation, take a print screen of everything along with your name and ID here. Go to simulate, place text, click onto your screen, write your name, ID 12S. Then take a complete print screen of your simulation. This is your first. Okay, the second part of the simulation is using your transient analysis. So for the transient analysis, we need a piecewise linear voltage source. The circuit is the same with R and L. For a piecewise linear voltage source, the input values are fed in the form of a table provided here, where the first value is always a 0, then the second value of time is exactly your time constant of the circuit. So here in the piecewise linear voltage source, we are providing the input. So when we provide the input, we have to start with the time value of time constant and increase slowly according to the value what we needed. So let us go get into the MultiSim and we'll take a new design, create. Let us place everything again. We need a resistor and inductor, then go to sources. Here you have to go for signal voltage sources. There you can find your piecewise linear voltage source. Place it. Then as usual our ground. Yes. Now connect a circuit. This is your ground. The values are 10 Henry and the resistor is fine. Now we want to give the input value for the piecewise linear voltage source. So to give the input, as usual, double click it. We'll get this window. Click on here. The first value is 0, 0, then 0, 2. The next time value will be our time constant. Okay, 0.025. Then let it go to -3. Sorry, 0.01. Then 0.025. Maintain till that. Once you feed it, say okay. That's it. These are the values we have to feed for a piecewise linear voltage source. Double click it and enter the table value. The table value for the time, if it is the waveform is not given, we are giving the input voltage, so it should start from the time constant. Okay, now go to simulate analysis. So it's not highlighted. Why? Because the previous simulations keep on running. So go back, stop that simulation and come back to this simulate analysis, transient analysis. Click that. So the start time should be 0 and the end time is 10 times your time constant. Your time constant was 0.01. So 10 times means it is 0.1. Okay. Then for output parameter, we want to see the voltage across the inductors. So we double click that, change the value to be VN. So it's this way. So we want that name to be displayed on it. Go back again. The end time is 10 times your time constant. V1 is your input voltage, VL is your voltage across your inductor. Then simulate. See, we got the output. So the red color one is your input and the green color one is your output voltage.